All right, so this is going to be about writing and graphing the equations of circles. This is going to be a readiness teak, so it's very, very important. And you will come across circles in or the equations of circles in upper grade levels. So one of the things you're going to have to be able to do is graph a circle. You're going to find the equation of a circle in the XY plane. You're going to find the center and radius given the equation of the circle and vice versa, and find the equation of a circle given the center and a point. So graphing a circle on a coordinate plane, we want to recall that the definition of a circle is the set of all points that are the same distance from the center. This definition can be used to find the equation of a circle in the coordinate plane. So XY represents a point on the circle. And then we have our center, which is going to be here on this example at the origin at 0, 0. Okay, our radius is going to go from the center to that point. Okay, which means we can use our distance formula or with the center and the point, or we can use Pythagorean theorem. Because our horizontal distance is x, our vertical distance is y, and our radius would be our hypotenuse. So they're going to start with a circle at 0, 0. If xy is a point on the circle, then the distance from the center to this point would be the radius. X is the horizontal distance, y is the vertical distance, and this forms a right triangle from the Pythagorean theorem. The equation of the circle is centered at the origin is x squared plus y squared equals r squared. Okay, and this is the basic equation of a circle with the origin at 0, 0. Okay, with the center at 0, 0. Okay, so when we're graphing this, here's my coordinate plane. My center is at 0, 0. Let me look at the example. X squared plus y squared equals 9. Okay, so x squared and y squared, that means my center is at 0, 0. And my radius is going to be, okay, well here it's r squared. So if r squared is 9, then the radius is going to be 3. Square root of 9 is 3. So my radius is 3. So I'm going to go up 0, 0. There's my center. Then my radius is 3 units. So 1, 2, 3. There's 1 point on my circle. What I like to do is I like to go up 3, because that's the radius of 3, to the left 3, that's a radius of 3, and down 3, that's a radius of 3. And then I can sketch it. Ooh, I don't have a compass or whatnot, and I don't think I can use my circle tool appropriately, but that is a terrible circle. I'm sorry, but that's how you graph it. Okay? So you start with the center, you find your radius. In the equation, that radius is squared, so we have to unsquare it. And then I go out horizontally 3 to the left, 3 to the right, 3 to the left, 3 up, 3 down, and then I can draw my circle. Okay? And here's a much better picture of it with the coordinate grid and probably some tools. Okay, so the center doesn't always have to be 0, 0. If not, then we label the center HK. So that differentiates it from XY being the point on the circle. And then we would use the distance formula to find the radius. So you can see that in our picture here that our circle is not at the center. It's at some point, HK, that represents our center point. XY is still a point on the circle, and then we have our radius. And we learned the distance formula the first week of school, so we know that, and we can calculate the distance for our radius. Okay, so here is our distance formula for our radius, we take the square root of x minus h squared plus y minus k squared. If you square both sides of the equation, then you're going to have the standard equation of a circle. So here is our standard equation of a circle. That's going to be right here. So the standard equation of a circle with the center HK and a radius of r is r squared equals x minus h squared plus y minus k squared. Okay, so sometimes they reverse these. You have the x minus h squared part plus y minus k squared part first equals r squared. And you can see an example too. It says find the radius and the center of the following circles. Now these minus signs are part of the equation. So you can see in the equation that the h is negative, but the center is the opposite of that. So if we have x minus 3, the opposite of that is going to be 3. Same thing with the k. In the equation, it's opposite k, but the center is positive k. So then we're going to take the opposite of negative 1, which is going to be 1. So that's our center. Okay, that's where the center of our circle is. 25 is r squared. Okay, so that's already squared. We would have to square root it, and our r would equal 5. So you're going to have to square root this number to get the radius. Okay, for part B, now it's positive. Okay, in the formula it's negative. So we have to take the opposite of that. So the opposite of 2 is negative 2. So that's going to be our x coordinate of our center. And then we have negative 5, and the opposite of that is positive 5. So we do have to take the opposite signs here. And then we have r squared is 49. It means it's already squared. That means we have to square root it. And our r is going to equal 7. Okay. They rewrite it using the negatives. Find the equation of the circle below. Okay, I'm going to increase make it a little easier to see. All right, so they say to find the center first. Draw in the horizontal and vertical diameters to see where they intersect. Okay, so horizontal would be this way. Vertical would be up and down. And where they intersect would be my center. And that appears to be at negative 3, 3. So my center would be at negative 3, 3. My radius, I would count horizontally 1, 2, 3, 4, 5, 6. And I want to check the other side. 1, 2, 3. Oops, lost count. 1, 2, 3, 4, 5, 6. So my radius is 6. So if I have my equation x minus h squared plus y minus k squared equals r squared, then I would go ahead and substitute in. X minus h, that's going to be the negative 3. Plus y minus 3. And that's going to equal 6 squared. So I'm substituting in, and then I'm going to simplify. So double negative turns to positive, so I get x plus 3 squared. This is going to stay the same, y minus 3 squared. And then I'm going to square 6, which is 36. So this is going to be the equation of my circle. That's the equation of my circle. Okay, so they have a video for you to watch. I think you can do that on your own. Okay, finding the equation of a circle. Determine if the following points are on x plus 1 squared, y minus 5 squared equals 50. Okay, so these are the x, y points. You want to see if these points are on the circle. So you're just going to substitute them in. And if it equals 50, then it's on the circle. If it's not, then it's not on the circle. So I'm going to take x plus 1 squared plus negative 3 minus 5 squared. I'm just substituting in because these points are x, y. And I want to see if that equals 50. 8 plus 1 is 9. So I'm going to have 9 squared. Negative 3 minus 5 is negative 8 squared. And I'm going to see if that's equal to 50. So I have 81 plus 64. And I can already tell that's not going to equal 50. They're both over 50. So that means that this is a no. This point is not on that circle. Okay, so for part B, I'm going to do the same thing. I'm going to label it x, y. I'm going to substitute those in. I'm going to have negative 2 plus 1 squared plus negative 2 minus 5 squared. And I want to see if that equals 50. I get negative 1 squared plus negative 7 squared. And I want to see if those equal 50. And I get 1 plus 49. See if that equals 50. 50 does equal 50. So that checks out. Yes, this point is on that circle. Okay, so to determine whether or not if the points are on a particular circle, you're just going to substitute those in. Okay, example 5. Find the equation of the circle with the center for negative 1 and passes through the point negative 1, 2. All right, so this is going to be my HK. And this is going to be my X, Y. And we have our formula X minus H squared plus Y minus, nope, X minus, yes, Y minus K squared equals R squared. Now, if you'll remember, and I may go ahead and pause this and make another video starting with example 5.